All right, let's get started. Good morning, everyone. The stragglers can catch up. Thank you for attending the webinar today from the lockdown. Another day, more education. It's great. Today, we're going to be talking about perfect digital workflows the Dental Access way. My name's Matthew Thompson, and I'm going to be presenting this. I'm the Technical Product Manager at Dental Access, and I look after the support team and new products as well, and I'm really excited to be giving this webinar today. So let's move forward. Digital workflows for crown and bridge in clinic. So this is a niche topic. Obviously, crown and bridge is a long established CAD/CAM product to be done in labs, and a few clinics are taking it up and more. I imagine many of you attending today are clinic-based professionals wanting to look at your options for manufacturing your own crown and bridge restorations in the clinic. So hopefully you can learn something and we can discuss some more. So what topics are we going to be covering? First, why are we going to do this in clinic? Also the requirements, and then workflows and the integrations. So why in clinic? Many of you will have done crown and bridge work, sort of single units or up to maybe 3-unit posterior bridges in the past. That's probably been going on for 20 or so years with some of the older CAD/CAM systems. But now you can get much more restorations, many more restorations rather. You can also get a very fast turnaround. You could turn around a crown in maybe half an hour or even an hour or so. It's really fast. So that's obvious advantages of having same-day dentistry. Your patient could come in the morning and leave in the afternoon with their final restoration. Maybe you want to make more use of an in-house lab that you've invested in. Maybe you've got a technician working for you, or you may be a prosthodontist who's got all the right equipment. Maybe you want some control over the process. Say, for example, you send 80 or 90% of your work off to the lab and you're very happy with, but some work you feel that you really want to have it this way. Maybe it's a particular aesthetic you're after or a certain material. So when I say choice over control over processes, I'm talking about choices of indication, whether it's a veneer or maybe a snap-on smile. You're doing a lot of aesthetic work maybe. As I said, the design and also the materials. Maybe you've got a certain brand you want to use, or you need a certain strength from your zirconia. Many reasons why you could want to go in clinic. So what's the workflow for an in-clinic crown and bridge restoration? As with anything in digital dentistry, there's 3 steps: scan, design, and manufacture. This is the same for all indications and for all materials. So let's have a look at some of the requirements. And you can see from this image here, I've got a bunch of different people's hands. Some have gloves, some don't. What this symbolizes that it is a combination. It's not just a clinician in isolation doing this. You may want to utilize an in-house technician or a nurse. Hence, I've got some different requirements here. So the scanner, typically the clinician or maybe a nurse or a hygienist will be using the scanner as laws dictate that it has to be an appropriately trained person. Also, when you think of equipment, you've got the investment in the equipment. Which scanner are you getting? Are you getting wired or wireless? Are you getting a color scanner? What are the different options? Also, the CAD software, you're going to have to design something, whether it's a crown or a bridge or a veneer and so forth. Which CAD software are you going to be investing in? And be aware that there may or may not be license fees associated with this that you pay to have the software developed ongoing by the software engineers all around the world, and other new features as well that always get added. Also, equipment-wise, you're going to have to get either a mill and or a 3D printer, and you're also going to keep a stock of consumables out the back in the cupboard. For many clinics, they don't have stock of restorative consumables like this. Of course, they have all their hygienic and clinical consumables, but it may be another thing to consider which consumables you have to keep on hand. And also the skills. So you may be a very experienced clinician, but you may have no experience with CAD. Are you the best person in the team to do the design? Or maybe you've got a young staff member who's a digital native, who's really tech savvy, who's really quick with the CAD. Or maybe you've got an in-house technician or another colleague who's got good CAD skills. There's also the maintenance of the equipment. There are some skills to that, making sure everything's clean, especially when it comes to milling wet, or if you're 3D printing, you need to take really good care of your machine. So the maintenance is very important. And the scheduling, whether one of your staff members has a daily or weekly schedule for certain maintenance, can you fit that maintenance into their existing schedule? And of course, the time as well. If that person that I just mentioned is doing this weekly or daily or however often it may be, can you fit it in? Or is it best that the technician does this? Whoever it may be, lots of things to consider as to what you need to get and who's going to do the work. So let's look at the requirements for scanning. Obviously, an intraoral scanner, you're going to have to capture the upper, the lower, and the bite using either a Trios or a Medit or another scanner you may have. Is this only a quadrant? Say you're doing a first molar. Do you need to scan both sides? Why not? But you can get away with just doing quadrant dentistry. Also, will you scan a pre-preparation? Scanning a pre-preparation is really helpful for the design, as we'll see later on with the live demo. So it's good things to consider when you're looking at what requirements there are for scanning. And being 2020, there's always new things to talk about, and I'm talking about other scans. Face scans are a huge part of dentistry now. You may have an iPad with the Bellus 3D app where you can pick up your phone and take some photos with that or swing it around you. And that way you can get a 3D face scan, which you can then align to the teeth and show the patient this is what your teeth could look like. This is extremely popular now with digital dentures in the lab, and of course with smile design for aesthetic cases, it's becoming very popular as well. So it's worth considering maybe investing in a 3D scanner that is stationary like a Bellus or a Face Hunter or many other brands, or getting an app that will do that for you. It's also a cool feature of the Medit. You can do a face scan with the Medit as well. I've done one with the Trios, just point it at your face, shut your eyes and scan from your teeth all the way up to your nose, and then align that with the full face scan. That way you can get a really accurate mapping. So some interesting thoughts about what requirements there are for scanning. Next up, we have requirements for CAD. Desired indications. So a lot of the CAD software you can get for clinical restorations will have a limited scope as to what indications are available. Of course, the lab software has all the indications, but we're talking about clinical in-house workflows here. So you have to think about which indications are you going to be doing? Do they fall under that limited number of clinical indications, or are you going to do more extensive work which involves the lab software, which is a much larger range of indications? And of course, these indications will then influence the licensing. The lab software will have higher cost and higher fees, but more ability. So what do you want to do? Is it within that range or is it not? And also the materials. The picture I have here from 3Shape, the table, it's got a bunch of machines and materials supported by Design Studio. You can see there's a different range of mills there, some and gearback mills, VHF, Roland as well, and a few others. And some of them are approved for, validated for certain materials of Ivoclar and Vita and 3M, all the names we recognize. Certain materials are indicated and supported by certain machines. So this is another thing to consider. Which materials are you wanting to use? Maybe you really like GC Serasmart. That will limit you to only the VHF, the Roland, and the Lyra. Or maybe you're an Emax fan. Then you can use almost any mill. So it's worth considering which materials and licensing you're going to look at. Say you want to do a certain indication milled in-house, but you don't have the design skills or the licensing to do that. Another option is to outsource the design to a lab or a design center. You take a scan, send it to them. They can design it in, let's say, 10 minutes, send it back to you. They're a professional designer, you're a professional clinician, sorry. That could be a good balance of utilizing what equipment and skills each location has. Now, integrations. When I say how many clicks, having everything in one software is really handy. So Trios Design Studio, for example, you scan, design, and mill all within the one software. That does have a certain range of application and works very well. Whereas Exocad chairside, for example, you can take in 5 or more different scanners and you can output to, 7 or even more different integrated mills or 3D printers. So it is worth considering what your scanner is, what your manufacturing options are, and where do you meet in the middle in terms of which CAD software is right for you. With that, let's do a live demo of some CAD software. So I've loaded one up just before, and this is my patient that we can see up the top left here called Webinar Lockdown with today's date. I'm going to choose in-house as my lab, and I'm going to do a 2-6. So I'm going to click on that molar, then I'm going to go over to the top left and click Anatomy, and I'm going to choose a material. Let's go with Smart LT. Choose a shade, let's say A2. I don't have a scanner here. I don't have a 2-6 that I can prep, so I'm going to cheat like any good TV chef, and I'm going to use one I prepared earlier. So I'm going to import a scan. So it's telling me to grab the upper jaw. So I'm going to grab my upper jaw scan. And I'm going to grab my lower jaw scan. And we can see here our optional scan, our pre-prep scan. I mentioned that just a few minutes ago, how using a pre-prep scan can really help with designing the crown. Now I've imported those, I need to make sure I tick the pre-preparation scan button here, so the software knows I have an upper jaw scan with the prep and a pre-prep. Now we've filled out our order form, let's jump ahead to the design. I'm going to show you a few features. I'm going to make a design. It's going to be a bad design. I'm not a dental technician, but I want to show you all the different features you have. First off, I'm going to clear the margin line. What we saw then was the software actually automatically detected the margin line for us, which is very helpful. So when I'm looking at the margin line, I can either turn the color on, and this can help me go, oh, I can see the margin line. I can see there's some troughing going on. It's a reasonably clean prep in that regard. This is quite good. But me personally, whenever I look for a margin line, I turn the color off. So I push T on the keyboard and the color disappears. As you can see, I can easily cycle through color on, color off. So I'm going to zoom in here, find a nice edge of my margin, single click, give the software a hint saying this is where the margin starts, and there it goes, bang. And in 2 seconds, it's run all the way around, followed the roller coaster of this margin, and marked it pretty well. It's also stepped out 2 or 3 millimeters and done a trim. That way I can see where my individual die is and verify this margin. Maybe I want to say, oh, actually it's there. I'm going to change that ever so slightly. Of course, I can play around with this to my heart's content, make it the perfect margin. But for brevity and for demonstration's sake, I'm going to say that's good enough. Next, we move on. What we're doing here is we're trying to find the insertion direction. And again, the software has taken my margin line and it's run a computer algorithm to say this is the optimal insertion direction to minimize undercuts. If we look here, due to this particular prep, there is a small amount of undercut here, 0.03. That's sort of almost down at the size of a single particle in cement paste, so I wouldn't worry about that too much. A few other spots. So that's a pretty decent insertion direction. And we can see here from this green arrow that this is a pretty decent insertion direction. If I wanted to overrule this and say, no, I'm better, I know what I'm doing, I can tilt the view to there and say from view, and that's going to change my insertion direction. We can see it's calculating the cement space, but it's warning us, oh, much bigger undercut. So in this case, the algorithm's better. So here we are, there's our very good insertion direction. And it's just recalculating the cement gap for me. Only takes a few seconds just so I can, again, verify the undercuts and know that my cement gap is well defined. The cement gap is defined by the material manufacturer. So I chose GC Smart before. GC have said for a posterior crown, you need to have a cement gap of this thick and a margin angle of this much and a width of this much. So taking all those predetermined values, throwing them into the software and giving us the perfect margin. We can see here that it's pre-designed a tooth for me. It's taken a library and morphed it to the margin line. So if I hide the jaw scan, I can see it's already cut to the margin line. put the cement gap in, and then we have a design. It may not be the design I'm after, but it is a design. I have a range of tools I can use. I can rotate my crown. Maybe if I look from an angle, it might provide a bit more view. So I can rotate this as much as I want. I can tilt it with the yellow. I can use the green to go up and down. I can make it taller and bring it further into occlusion. Of course, this may not be a particularly good design, but again, it's a design for demonstration's sake. Or what I can do, I can click on one of these green buttons, hold down Control on the keyboard, and then I can grow the tooth in every dimension. So forward, back, up, down, left, right. And you can see I've got this monstrous tooth here. Again, probably not a very good design. I have a few other options as well. I can morph, so I can take these control points, move one side down. In this case, I'm moving the buccal side down, or I can move that particular cusp, or I can go directional. We can see here a nice example of this is I can make a control circle here, and I've got this arrow pointing away from the surface. As I rotate around the surface, you see that arrow move. So I can say, oh, I want to make a little blob like this. So you can play around to your heart's content to get the most amazing design. I can add some wax in there. I could maybe make a really small fissure in here if I wanted to add some anatomy details to it. I imagine by now a lot of you are looking at this and going, this is a terrible tooth, Matthew, please stop. So I'm going to stop. Let's go back to a new design. Now we'll show the pre-preparation scan, as I talked about before. So there we've got my generic library tooth. I'm going to shape this to be almost as big as the pre-prep. I can look from the side here, maybe make it semi-transparent, drop it down a little. So now I've got my design tooth and my pre-prep from before. I can use the really clever tool over here, morph to pre-preparation. One click, and it's going to shape this tooth down to fit that blue scan exactly as I've defined. So give it a moment, and it's going to shape the tooth to what we had before. So there we go. Our tooth is exactly the same as the pre-preparation. But we can see this red area. That means it's not quite thick enough. So I'm just going to finish this design off, cut to the margin line so we know that we've got a valid shape. Then I can enforce the minimum thickness of, say, 1 millimeter. And it's going to fatten up this red area here. Maybe I just want to gently smooth over these edges here. Play around to your heart's content until you have the exact design you desire. Hard contacts with the adjacents. So look here, we can see there's a contact there. If we look through the other tooth as well, there's quite a hard contact there. Maybe I can go in and just paint on where I want the contacts to be. Maybe through there, hit play, and it's going to automatically cut those contacts for me. So now we can see the contacts are exactly how I desired. Saying thin design, again, I can quickly correct that, and then I'm going to move on. So that's just a nice example of some of the tools available. Again, it wasn't meant to be the prettiest crown you've ever seen, but just an example of what options there are when it comes to designing a crown, what tools you have. Finally, once I've designed my crown, I can send it off to the mill. So I've loaded here the Roland DWX42W. Some of you may recognize the holder. And you can see it's automatically placed the sprue and placed the crown in the block. I can choose a larger or smaller block if I want. I can choose a slightly bigger block, and I can choose whether to have standard definition, which would use the 2 millimeter and the 1 millimeter tool for roughing, or I can add the high definition. And we can see down the bottom right of screen here, it's added a third tool, which is the 0.5 millimeter tool. That gives us the really fine anatomical detail. When I'm ready, I can hit produce, and it will go off and mill. Very good. Now I'm going to do another quick design. I'm going to do a screw retain crown. So I'm going to make a new case, and we're going to look at some of the functionality available in Trios Design Studio for the functionality here of designing a screw retain crown. So here we go. We're going to choose our lab. I'm going to do in-house again. I'm going to choose the 1/6, and I'm going to choose an abutment, and it's already preloaded for me, screw retain crown. And it's given us the option here on the right side of screen for the emergence profile. I'm going to quickly import some scans. So I'm going to import the upper jaw scan body. Then I'm going to do the lower jaw, and I'm going to do the gingival scan. And I'm done. Pretty easy, as if I'd done the scan. Scanning's that quick anyway. Now I'm going to go and align my scan body. Oops, I've done the wrong scan. Sorry, wrong order. Bear with me a moment. That's the beauty of digital dentistry. If you do it wrong, you can always go back and undo it. There we go, all done. And now I can go align my scan body. Now, I'm not going to claim to be amazing, but I just happen to know that this is an ELOS scan body for a Straumann bone level, and it's an RC. So what I can do, I can click 1 point on there, 1 point on there, and you can see we've got this beautiful alignment of the virtual scan body in my library to the scanned scan body. So that's a really nice alignment. We can see it's less than 20 microns deviation over the vast majority of the scan body, especially the flat surfaces, which we use for rotational alignment, and the flat surface on the top, which we use for height alignment. So again, the software has proposed a crown for me. Let's say, for example, that I want to do a custom healing abutment, something with very little anatomy. You don't want to be in contact with the antagonist. Why don't I go to the Smile library, and I can go choose the Lee Culp Mature library, which has very little detail. I can then drop it down so it's out of occlusion. We can see here it's well out of occlusion. Maybe just a touch higher so it's not interfering with the tie base. And then I can get the wax knife, I can go smooth, I can make it really big, and I can just remove all the anatomy. So it's a fairly dull crown. Maybe I can hide my neighbors. I can just say this is going to be a very smooth crown, purely for the purposes of a custom healing abutment. So that's done. There's my generic shape, maybe just a touch off there and a touch off there. If you wanted to, you could add more detail, but again, for the purpose of a custom healing abutment, not really necessary. Then we'll say next, and we're going to step forward to where we do the emergence profile. So we can see here that we've got a bunch of control points which have snapped fairly well to the shape. Maybe that one could come in and up a little. Maybe this one can go out a little. But again, you can play around to your heart's content to get the perfect emergence profile. I'm going to say that's good enough, and we'll say next. So there we go. It's taken my design, taken my emergence profile, put them together, and put them on a tie base. There we go. There's our particular tie base. We can sculpt this further if we really want. Maybe I want to, I don't know, quickly engrave my initials on here. Let's make that really small, really strong. MT. So I know that this is for Matthew Thompson's custom healing abutment when he gets his implant placed. And next we move on to the screw hole. So we can see here, this is just a quick screw hole done very easily. I can add extra radius if you want, add more cement gap if you know your mill needs a little bit more gap to mill perfectly. Then I can click save, and it's going to save this STL for me. I can then send that off to whichever CAM software I've got. I'll just quickly open the folder that comes with it, and we have our lovely STL along with our PTS and XML. So if you've got Millbox, say, for your roll and mill, or maybe you want to 3D print this, you can quickly take that STL and send it off to the milling machine. Right, so now that we're talking about milling machines, let's move on to some requirements of manufacturing. What do you have to consider? Well, there's the physical considerations. You're going to have a bench top free, possibly. Some of these roll and mills are 50 or 60 centimeters wide or so, such as the 42W wet mill on the left, top left of screen. Or if you're wanting to mill zirconia, you might have the 52 DCI, which has got the loader on the side. So that's a bit wider, a bit heavier. Do you have a bench that's strong enough? Do you have compressed air? What things do you need for milling? This also goes into which indications are you going to do. Are you going to do wet or dry or both? Would you get 2 separate roll-in mills for wet or dry, or would you get, say, an iMes-iCore 250, which can do both, but will need more maintenance for cleaning? So some good considerations there. What about 3D printing? Do you have enough space to fit, say, a Form 3B, or maybe you want something bigger like a Rapid Shape? Do you have the space for that? What about the cleaning and maintenance? So for a 3D printer, many of you will know that there's the resin to be maintained, there's the IPA, there's the curing light, there's going to be smells associated with this. Same with the maintenance of any wet mill. You're going to have to worry about maybe some glass ceramic paste will get into the mill. You have to be very vigilant about cleaning this. So just some considerations for the size and shape and space for the machine, and also what's involved with it during day-to-day use. What about the post-processing? I just spoke about the IPA. This can be labor intensive depending on what equipment you have. Maybe you've got an ultrasonic bath which has a dirty and a clean. Maybe you've got something like the Rapid Shape wash and cure, which are all automated. Less labor. You just say which job you did. It automatically does the washing and curing programs for you. All you have to do is put it in and hit go. This may be a bit more equipment intensive with a bigger investment in this equipment if you're going to have an automated system like the Rapid Shape. There's also going to be the time delay. So say you've 3D printed a crown in half an hour. There's going to be 10 minutes of washing, maybe 10 minutes of curing, maybe a bit longer depending if your particular material requires nitrogen or a vacuum to ensure that it gets a lovely surface finish. What about the strength of the material? Is printing better than milling? What about biocompatibility? Some 3D printed materials are only biocompatible if you follow a very strict routine as to your post-processing. So it's good to think about not just the print or mill on its own, but what happens afterwards? What extra time does that add to it? Just to have a quick summary of all these things, I've done a little table here just showing some examples of materials that you could mill or 3D print. The machine timing is all much of a muchness, 20 to 30 minutes. I don't think a patient's going to say no if it's 25 instead of 20 minutes to have their crown milled in glass ceramic instead of, say, PMMA. What about the block size? So if you're milling glass ceramic, you can only get it in like a thumb-sized bridge, up to maybe 3 units or so. But for the post-processing, you're going to have to fire it. Whereas if you're doing PMMA or zirconia, you could get this in a disc, or you could get it in a thumb-sized block. Say it's PMMA, you only have to polish it. That's much quicker post-processing than glass ceramic is. Same with a hybrid ceramic. You can do up to 3-unit bridges. All you have to do is polish it. But zirconia, you have to sinter it, depending on what sintering cycle you use. I know a lot of labs use an 8-hour sintering cycle, which some of you may go, oof, 8 hours, that's enormous. If you're doing a single-unit crown, some people have developed much faster sintering cycles. So all these post-processing things are worth considering. Same with the 3D printing. Whether you've just got a regular temp resin, you're going to have to use some IPA and you're going to have to cure it as well. How many litres are the bottles bought in? Most are bought in 1 litre bottles. Some of you may have seen a previous webinar I did on 3D printing, where the Rapid Shape printer, the capsule printer, has these small single-use cartridges, a bit like the cheese and crackers things that kids take to school for their lunch. You get the cheese and dip it in the sauce. It's a similar size thing, similar usage. You have enough resin to print maybe a 3-unit bridge, maybe a surgical guide, something small. The advantages of that are you don't have to store litres of resin. Or maybe you've got a glass-loaded resin, like the new Ceremco material. That comes in half a litre. That's quite a gluggy material and it needs to be warmed. So you have to think about, if I want to print quickly, maybe I need to preheat my resin. So lots of considerations around your whole workflow, not just which mill you buy and what it says on the packet. So let's think now about milling indications. As I said at the very start of the webinar, crowns and short span bridges have been around for 20 or so years with some of the older equipment. Now we're moving into more complicated work like temporary crowns or virtual wax-ups for diagnosis, or veneers. If you want to do really, really thin veneers, what's the best way to do it? Is milling the best way? Often you can get a really nice result with some really good materials. as I said just a few minutes ago, which blocks can you purchase? They're typically in 1 to 3 unit size of your thumb is the standard size. With milling, you're buying high quality factory made materials. If you think of zirconia, you can't make zirconia at home. It's just not possible. You need to have all the right materials. You need to have an iso press. Similar with PMMA, you could mix up some acrylic and pour it in, but it's not going to be dense. You need a big machine to force the PMMA and make it really dense and really strong. I haven't seen a quick YouTube video on how to make my own glass ceramic. Neither have I seen a glass loaded hybrid material. So you're buying really strong factory made TGA certified materials when you're milling. If you want to do larger things such as a bite splint or larger bridges, you'll have to then consider a 5-axis mill to ensure that there are no undercuts and you get a nice seating. But the other consideration then is, are you becoming a lab? Is this what you want to do? What range of indications are you want to restrict yourself to intentionally? We have a few customers in country Queensland who are their own lab because they're out in miles away from Brisbane or other major cities. So they do have to have all this equipment, and that gives them more opportunities to service their patients better. Bite splints, let's just quickly jump back on that. A lot of people talk about whenever you place a crown or any other restoration, you need to put a bite splint in at least for a few months to ensure that the restoration doesn't wear away as the patient grinds with their teeth. And then on to screw-retained crowns and custom healing abutments. Many of you will have seen the news at Chicago that the 42W from Roland can now do custom healing abutments. If you want to mill titanium, you can do that as well, similar to the example I just did in my live webinar as well. And also, with the mill, do you want it to be integrated into your CAM software as the Trios Design Studio I showed you just was, or are you going to be using a separate CAM software? So a lot to consider there. A few sort of yeses or nos to think about when you're looking at doing in-house clinical restorations. Now let's get to the exciting bit, printing indications. You can see I've got a swathe of pictures on the right side of the screen there. The top one is from Asiga from their brochure. They've got 380 materials, which seems quite ridiculous. They've got 12 different companies listed there. If you do the maths, that's quite a few different materials per company. Some like GC only have one, whereas NextDent and DTAX have many. You can see the bottom right, I have DTAX's list of different materials. You can print denture bases, temps, splints, more and more materials are being made every week. It seems more and more indications are available. Some of these are quite useful for clinical applications, such as splints and maybe try-in dentures. So it really comes down to what bottle can you buy? And what bottle can you buy is, of course, limited by the TGA or FDA or a CE mark, depending on where you are in the world. Is it biocompatible? This, of course, does influence the TGA approvals. How strong is the material? Which then leads to, is it a temporary or a long-term temporary, like 5 years, or is it permanent? Many of the denture materials and for teeth and the base, of course, but also the teeth materials can be used as just regular crown and bridge temporaries. If they're TGA approved for one, they're likely TGA approved for both. So you can see there's an enormous list of different materials you can use here. So do have a think about what you want to do. This will influence which materials you want to buy and then which printer you may want to buy. Different printing brands have validated workflows for different materials. So a huge amount of information. Thank you everyone for attending. It's been really good to talk some more about what your options are for in-clinic crown and bridge restorations. If you do have any questions, please reach out to us. We're still operating. We're working from home at the moment during the lockdown, so we're on the phones. Give us a call, or you can check us out on social media, LinkedIn, Facebook, Instagram, of course, or send us an email, support@dentalaccess.com, and please sign up to the newsletter. Any questions, please do get in touch. Thank you very much. Goodbye.